So guys, in our previous video we have seen the electrophilic substitution reactions of our chlorobenzene, and we saw there with respect to the three important reactions. One was your halogenation, nitration, and also the sulfonation part. And we came to know that whenever the chlorobenzene or that of your aryl halides are undergoing the electrophilic substitution reaction, we are getting major products and a minor product. That is, a combination of the two products are obtained. One will be a para-substituted product and another will be a ortho-substituted product. And of course, in today's video, we are going to see the most important other two electrophilic substitution reactions of our chlorobenzene, which in overall is called as a Friedel Craft's reaction, or it is called as Friedel Craft's reaction. Friedel Craft's reaction. So basically this Friedel Craft's reaction is a very much important topic because it will be seen in also in other organic chapters also in a different way, but the names will be the same. That is, we'll be doing this Friedel Craft's reaction. Basically they are categorized into two important types. One is called as a Friedel Craft's alkylation. Once again, I am reminding you, it is a named reaction, so very much important. Friedel Craft's alkylation and Friedel Craft's acylation. Friedel Craft's acylation. Of course, Friedel Craft is the name of the scientist who have discovered this reaction. So basically, first and the foremost thing, let us see Friedel Craft's alkylation. Friedel Craft's alkylation. Once again, I am reminding you, this Friedel Craft reaction is once again we are seeing in the electrophilic substitution reaction. So just recall the concept of the electrophilic substitution reaction. What is that? We have to use the chlorobenzene and we need an electrophile. Of course, now here what we are going to see, what is the electrophile we are going to use in our Friedel Craft's alkylation. Remember guys, when you are treating your chlorobenzene, when we are treating our chlorobenzene with, yes, methyl chloride, remember, in the presence of our anhydrous aluminium trichloride. I repeat, when we are treating our chlorobenzene with a methyl chloride in the presence of anhydrous aluminium chloride, of course, what we are going to get? Yeah, so we know that our halogen will be retained, but whatever the electrophile is there, that is going to get attacked in the para and the ortho position. That is what here CH3 we are going to get, and over here we are going to get in the ortho position our methyl group attacked. You are able to see. So basically, what will be? This will be 1, 2, 3, 4. So how will you name it? Yes, 1 hyphen, then capital C. Then what you have to write? Yes, hyphen 4 hyphen methyl benzene. Similarly over here, how will you write it? Yes, 1 hyphen capital C chloro hyphen 2 hyphen methyl benzene. Alva. So which one will be the major? Of course, our para substituted product. So this will be the major, this will be the minor. Why is it so? See, chlorine is also having electron rich, whereas methyl is also, we know it's an electron donating group. So mutual repulsion agutte. Adeli jasti irutte mutual repulsion in the ortho position. Avage enagutte stability kadme irutte. So avagante quantity enagirutte kammi sigutte. Adeli enagide, they are far away from each other. So there will be less steric hindrance between them, and also moreover they are symmetric and easily fit into the crystal. So they will be in a major yield. Now the question arises that how does this reaction takes place? Once again, an additional information. For your exam, you have to just, they will be asking you what is Friedel Craft's alkylation. First you explain this reaction in your words and then write this reaction. Can you try with me now? Of course, when I was doing my halogenation reaction, there also I have said in the presence of anhydrous FeCl3, we can use our anhydrous AlCl3. Why did we use over there anhydrous FeCl3? Because to generate an electrophile. In the case of halogenation, the electrophile was chloronium ion. But here what we are getting, the electrophile is our methyl group, CH3+. So methyl carbocation. Can you please help me out how we are going to do? Yes. So what you are doing, CH3Cl, when it is treated with that of your anhydrous AlCl3, what it will do, of course, now CH3 ಮೇಲೆ plus ಬರಬೇಕು, Cl na AlCl3 ಹೇಳ್ಕೊಳ್ಳುತ್ತೆ. Why? Because anhydrous AlCl3 is a Lewis acid and also it acts as a catalyst. Lewis acid ಅಂದ್ಕೊಳ್ಳಿ ನಿಮಗೆ ಏನು ಬೈಂಡಿಂಗ್ ಬರಬೇಕು, it is going to attract the electrons towards itself, ಅಲ್ವಾ? And catalyst ಅಂದ್ಕೊಳ್ಳಿ ನಿಮ್ಮ ಮೈಂಡಿಗೆ ಏನು ಬರಬೇಕು, it has to be regenerated back at the end of the reaction. So what will be happening over here? Yes, CH3 plus ಬರುತ್ತೆ, plus you are going to get as AlCl4 minus. I will be just showing in my ortho position. So ಏನಾಗುತ್ತೆ, ಯಾವ ತರ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ ಅಂತ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ನ ತೋರಿಸ್ಕೊಡ್ತೀನಿ. Cl ಇರುತ್ತೆ, ಸೊ ಇದೇನಾಗುತ್ತೆ ಪ್ಲಸ್, ಈಗ ನಮ್ಮ ಹತ್ರ ಏನುಂಟು ಎಲೆಕ್ಟ್ರೋಫೈಲು ಮಿಥೈಲ್ ಅಯಾನ್. ಸೊ ಇದೇನಾಗುತ್ತೆ, this will interact with that of your pi electrons of your benzene. You can just see from negative to positive only you should write the arrow mark. So this is the way, you should never write in the opposite, it will be a wrong concept. So ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿಂದ ಬಾಂಡ್ ಈಗ ಶಿಫ್ಟ್ ಆಯಿತು, ಆ ಬಾಂಡ್ ಇಂದ ಏನಾಯ್ತು, CH3 ಜೊತೆ ಒಂದು ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಅಲ್ಲೇ ಒಂದು ಹೈಡ್ರೋಜನ್ ಇರುತ್ತಲ್ವಾ, C6H5. ಸೊ ಅವಾಗ ಏನಾಯ್ತು, ಬಾಂಡ್ ಇಲ್ಲಿ ಒಂದು ಬಾಂಡ್ ಉಂಟು, ಇಲ್ಲಿ ಒಂದು ಬಾಂಡ್ ಉಂಟು, ಈ ಬಾಂಡ್ ಏನಿತ್ತು ಇಲ್ಲಿ ಬಾಂಡ್ ಆಯ್ತು, ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಈಗ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಸೊ ಅದನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಸೊ ಈ ಹೈಡ್ರೋಜನ್ ಇಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ, ಆ ಹೈಡ್ರೋಜನ್ ಅಲ್ಲಿಗೆ ಹೋದ್ಕೊಳ್ಳಿ ಏನಾಯ್ತು, ಇಲ್ಲಿ AlCl4 ಮೈನಸ್ ಇತ್ತಲ್ವಾ, ಇಟ್ಸ್ ಅನ್ಸ್ಟೇಬಲ್. ಸೊ ಒನ್ ಕ್ಲೋರೈಡ್ ಅದು ಕಡೆ ಹೇಳ್ಕೊಂಡು HCl ಆಗುತ್ತೆ, ಯಾಕೆ H+ ಹೊರಗಡೆ ಬಂದಿರುತ್ತೆ, ಇಲ್ಲಿಂದ ಅದು Cl- ನ ಹೊರಕೊಡುತ್ತೆ. ಸೊ H+ and Cl- gives you HCl plus AlCl3, ಅಲ್ವಾ? So this is the way. Similarly, you can also try with that of your para. Try it so that you will get to know. So when you are trying for the para, do remember to write the arrow mark. How you are going to write? From the negative towards the positive. See the way, same way you have to just write a bond representation, numerical ಮಾಡಿ ಒಂದ್ಸರಿ you can confirm by yourself. So this is the way. Question arise agutala, why we have taken anhydrous AlCl3? Because it is acting as a Lewis acid as a catalyst. With the help of the anhydrous AlCl3, we are able to provide the electrophile, that is your methyl carbocation. So this was called as what? Friedel Craft's alkylation. Similarly, when we are going with the another important reaction, what it is? Yes, it is called as a Friedel Craft's acylation. So what we are going to see is now it is called as what? Friedel Craft's acylation. So what is this Friedel Craft's acylation is very much important. So what we did over here in a Friedel Craft's alkylation, I have taken alkyl halide. Yes, that is our methyl chloride. Similarly, when I am talking about Friedel Craft's acylation, I am going to take an acyl halide, or in more particularly acyl chloride. So ಏನಾಗುತ್ತೆ, when we are treating our chlorobenzene, yes, over here, so this is my chlorobenzene. This will be treated with what? Yes, our acyl chloride. You just see the part CH3COCl. I repeat, CH3COCl. It is called as what? Acyl chloride. What it is called as? Acyl chloride. And do remember, whenever we are conducting a Friedel Craft's reaction, we require what? Anhydrous ANH1. Anhydrous AlCl3. Okay. So illenagutte, can you please help me now? Of course, alva. Illenagutte, AlCl3 will take that of your Cl towards itself. So now the question arises that how your electrophile will be, alva. Because here, however, you are having CH3. I was knowing that C was having the positive charge, and do remember the bonding is with respect to the carbon atom. But here now the question arises that where does the positive charge will be, whether on this carbon or this carbon. Do remember, when I am writing the product, you will get a hint. Then we will look after its mechanism also, which will be an additional information. So now here you will be getting as what? COCH3. I hope you have come to know on which carbon the positive charge is. Similarly, Cl, COCH3. And do remember guys, while naming this, I want to say you something. So when your benzene is directly attached to that of your C double bond O CH3, alva, CO means it's a ketonic group, alva, COCH. So this compound has been given with a name called as an acetophenone. What it is called as, one of the important compound, what it is called as acetophenone. So taking now this one as my parent chain, what I will do, I will take my halogen as a substituent. So again anta number ಮಾಡಬಹುದು 1, 2, 3, 4. Yes. So how can you name it? 4 chloro, alva, 4 chloro acetophenone. 4 chloro acetophenone. In the previous case, what did I took? I took my benzene as the parent chain. For that reason, I took my chlorine as a methyl group as the substituents. But what did I do over here? I have taken my acetophenone itself as a parent chain and I am taking my chlorine as a substituent. So that is the reason I am numbering from my acetophenone. That is my functional group ira kadeyindane number ಮಾಡ್ತಾ ಇದೀನಿ. Similarly over here when I am taking, yes, 1, 2. So how will you name it? 2 hyphen capital C chloro acetophenone. Acetophenone. So can you please help me, which will be the major? Yes, the para will be the major. So 4 chloroacetophenone will be the major, whereas 2 chloroacetophenone will be the minor. Is that clear? Now the question arises that how this reaction is taking place. I am saying it's an additional information. So of course we came to know that whenever we are talking about this AlCl, it's acting as a Lewis acid as a catalyst. So it is CH3COCl when it is treated with the top of your anhydrous AlCl3. What it is going to give, remember, CH3CO plus is in this way. That is the carbon which is bonded to the oxygen and the methyl group will be having the positive charge. Is that clear? Why so? Just you see, when I am writing my CH3COCl, how will I write it? Yes, in this way, alva. So what my AlCl3 is doing, it is taking overall this Cl along with its electrons. So again I do 1, 2, 3. So carbon is not being satisfied with the tetravalence, so that will be having what? Positive charge. So that is the reason carbon which is attached to the oxygen and our methyl group will be having the positive charge. So now this carbon is acting as what? Which will be having a positive charge, will be going to bind our chlorobenzene. So once we are going to get that part, how we are going to react is NCl plus that of your CH3CO plus, or you can also write as a COCH3, also no matters. And do remember, when you're writing the product, we have to be very careful. We have to write it as what? COCH3. Never write as CH3CO. If you write as like this, Cl and CH3CO, it is wrong. Why it is wrong? The concept will be wrong. Whatever the bonding you are writing is with respect to the carbon, which is with the methyl group you are writing. But we know what from the mechanism, that carbon is not bearing any positive charge. So of course it cannot act as an electrophile. So which carbon you have to mention? So be specific when you are writing the bonded carbons. So very much important, whenever you are writing an electrophilic substitution reaction or nucleophilic substitution reaction, you should take an uttermost care for the substituent for which you are writing. That substituent's particular atom will be bonded to our main parent aryl halides. Is that clear? So this was the concept which was said as an electrophilic substitution reaction. So in today's video, what we have seen is a Friedel Craft's reaction. In that Friedel Craft's reaction, we have seen the two important reactions, which is called the Friedel Craft's alkylation, Friedel Craft's acylation. So in a Friedel Craft's alkylation means what? So when a chlorobenzene is treated with a methyl chloride or a chloromethane in the presence of, that is very much important, don't miss this. In the presence of anhydrous AlCl3, we are going to get 1 chloro-4-methyl benzene and a 1 chloro-2-methyl benzene. So this reaction is called as what? Our Friedel Craft's reaction. And do remember, whenever they have been asked you to write any reaction, first you have to explain it in words, and then you have to give the corresponding reaction. And do mention, try to remember their names. Of course, I'm showing you in all the videos at how to write the names. Don't by heart it. So Elaine Maridevi, we have taken our benzene ring as a parent chain and the two other substituents as their, and two other groups as their respective substituents. So numbering, you have to take the number in a proper way, so easily you can write it. So why we have used, what is the mechanism, what is the electrophile generated in a Friedel Craft's alkylation? It's an alkyl carbocation. Okay, so that is CH3 plus, which is going to interact with your pi bond of your haloarenes, and you'll be going to get your respective products. Whereas when you are coming with respect to the Friedel Craft's acylation, don't get confused, it is what? Alkylation, whereas it is what? Acylation. I will be saying why we have used the particular words. Of course, you have also come to know, but once again I will be saying it. But when you are treating your chlorobenzene with an acyl chloride in the presence of anhydrous AlCl3, don't forget, again and again I am saying, don't forget to write this part, anhydrous AlCl3. Remember, you are going to get as what? 4-chloroacetophenone and 2-chloroacetophenone. Here what we have done, we have taken our parent chain as that of your acetophenone. Acetophenone means what? The benzene ring which will be attached to a COCH3 group. So it is called as what? Acetophenone. So that one, so in that case what happens, whatever our halogens will be there, they will be acting as a respective substituents. So here also you have to take an uttermost care. The new electrophile which has been generated, that a positive charge will be on our ketonic carbon group. So whenever you are writing the bond, however the substituent, so you have to write more particularly which carbon, COCH3 itself you have to write, never write as CH3CO. It will be a wrong concept. Again and again I am mentioning. So when we were writing for a chlorine, of course I have shown you chlorine no matters, you can easily write. When you are writing for the nitration, yes, N should be bonded to our benzene ring. When you are writing for the sulfonation, S should be bonded to our benzene ring. When we are writing for the Friedel Craft's alkylation, CH3 groups C should be bonded to our benzene ring. When you are writing for the acylation group, CO or the carbon atom of your ketonic group should be bonded to our benzene ring. Coming to the name remembrance, see here. Why it is called as an alkylation? Because here we are taken as what? We are taken as an alkyl group, CH3 group is what? Alkyl chloride. What it is called as? Alkyl chloride. So that is the reason we have taken as the name as what? Alkylation. So this is a hint to remember this reaction. Similarly, Friedel Craft's acylation. Why we had used as an acylation? Because here we are using what? Acyl chloride. By the name of acyl, we are given it as the name of an acylation. By the name of an alkyl, we are given the name as what? Alkylation. Friedel Craft is the name of the scientist or chemist who has discovered this reaction. Is that clear? Very much important. You have to keep sure that you are remembering all these named reactions. Okay, very much important. Once again, I am repeating. Don't ever try to forget to write this anhydrous AlCl3, and importantly, two products also you have to mention. One will be our para, another will be our ortho, and do remember, para will be the major, ortho will be the minor. Is that clear? Okay. So next we are going to see how does our aryl halides are going to react with the metals. So before going to this reactions, I would just like you to recall the concept. How does our alkyl halides, I repeat, how does our alkyl halides were reacted with the metal? And more particularly, I would just like to recall the Woods reaction. What is that? Woods reaction. Because that concept will be taken here once again, and you will be seeing by the coupling reaction. A concept of coupling reaction we are going to see, in which we are going to use both the concepts of our alkyl halides in the presence of sodium and the aryl halides in the presence of sodium. So guys, what have you recalled? So I told you to record the reaction called as our Woods reaction. Woods reaction. So what is this Woods reaction? So of course Woods reaction means what? Whenever we are treating our alkyl halides, yes, that is 2 moles in the presence of our sodium metal in dry ether. in dry ether. What was the product we have got? Yes, I'm giving you the 3 seconds. Recall fast. Alva. So basically we are going to get a CH3. That is, it's called as a coupling reaction. So what do you mean by coupling reaction? Remember. So coupling means what? Couple. Alva, couple anta heltivi. So couple andre artha enu? When the two fragments, it's a reaction in which two fragments are being joining. Alva. CH3x ಮತ್ತು CH3 ಅದಕ್ಕೆ ನಾನು 2 ಟೈಮ್ಸ್ ಅಂತ ತಗೊಂತೀನಿ. CH3x ಒಂದು CH3x ಒಂದು. ಸೊ ಏನಾಗುತ್ತೆ, ಅದು ರಿಯಾಕ್ಷನ್ ಮೆಕ್ಯಾನಿಸಮ್ ಬರೆದಾಗ ನಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಫ್ರೇಗ್ಮೆಂಟ್ಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ದಟ್ ಇಸ್ CH3 ಮತ್ತೆ CH3 ಅಂತ ಎರಡು ರಾಡಿಕಲ್ ಫಾರ್ಮ್ ಆದಾಗ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಆ CH3 ಏನಾಗುತ್ತೆ, 2 fragments. So the reaction in which the 2 fragments are joining together in the presence of our respective metal or in the presence of a metal. So basically in the Woods reaction we have taken the sodium. It is not necessary that only sodium can be used. You can also use the activated copper. You can also use a magnesium metal. You can also use your lithium metal, zinc metals. So these metals can be used. But particularly we are dealing with the Woods reaction. So that is the reason I am saying sodium metal. So ಏನು coupling reaction andre? It's a reaction in which the two fragments are being joined in the presence of a metal. So such reactions is what called as coupling. Alva. So you can only see here. So it is what as coupled product. So such reactions are called as what? Coupling reaction. Why did I say this? You'll come to know when I'm going with my third reaction. But now I want to treat that how does my aryl chloride, that is to be more specifically I want to say that how does my chlorobenzene is going to react with my sodium metal. So basically it has been given with a name called as what? Friedel reaction. What it is called as? Friedel reaction. So what is this Friedel reaction? It's similar to that of your Woods reaction. But in Woods reaction what did I took? I had taken my alkyl halide. Whereas in my Friedel reaction, yes, I'm going to take my chlorobenzene. That is my aryl halide. So when I'm taking my Cl part, remember Cl plus, so this is also 2 moles of my chlorobenzene in the presence of sodium metal. Remember, medium is very much important. That is dry ether. That is called as what? Dry ether. So what I'm going to get? Yes. So see the product, very much important. Coupled ಆಗಿರುತ್ತೆ. ಏನಾಗಿದೆ coupling ಅಂದ್ರೆ CC bond ಆಗಿದೆ ಅಲ್ವಾ? So ಇಲ್ಲಿ ಕೂಡ ಏನಾಗುತ್ತೆ, in this way we have to write. Are you able to see? ಇಲ್ಲಿ ಕೂಡ ಏನಾಗುತ್ತೆ, this C and this C has been bonded alva. So this is called as what? It is called as a diphenyl, or it is also called as what? Biphenyl. In both the words we can say. Please make sure how I have written, very much important. Don't get confused and write it in this way. ಈ ತರ ಬರೆದ್ರೆ ರಾಂಗ್ ಆಗುತ್ತೆ ಅಲ್ವಾ? ಸಮಟೈಮ್ಸ್ ವಿ ಕ್ಯಾನ್ ಗೆಟ್ ಅ ಕನ್ಫ್ಯೂಷನ್ ಅಂಡ್ ವಿಲ್ ಬಿ ರೈಟಿಂಗ್. ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಅದೇ ಸಿ ಜೊತೆ ಬಾಂಡ್, ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ದ ಫ್ಯೂಸ್ಡ್ ಪ್ರಾಡಕ್ಟ್. ಇದೇನಾಗಿದೆ, ಫ್ಯೂಸ್ ಆಗಿದೆ. ಸಾಲ್ಡರ್ ಮಾಡ್ತೀವಲ್ಲ, ಸಾಲ್ಡರಿಂಗ್ ಮಾಡಿದಾಗ ಏನು ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಕೂರುತ್ತೆ, ಅದಕ್ಕೆ ನಾವೇನು ಫ್ಯೂಸ್ಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. ದಿಸ್ ಇಸ್ ನಾಟ್ ದಿಸ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ಟೋಟಲಿ ಡಿಫ್ರೆಂಟ್ ಫ್ರಮ್ ದಿಸ್ ಪಾರ್ಟ್. ಓಕೆ, ನ್ಯಾಫ್ತಲಿನ್ ಇದು ಆಕ್ಚುಲಿ ಹೇಳ್ಬೇಕಂದ್ರೆ ಅಲ್ವಾ, ನ್ಯಾಫ್ತಲಿನ್ ಬಾಲ್ಸ್ ಬರುತ್ತಲ್ವಾ, ಅದ್ರದ್ದು ಈ ಪಾರ್ಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ಡೋಂಟ್ write this. So this is called as what? Diphenyl or a biphenyl, where you can just see a CC bond. So such reaction is called as what? Friedel reaction. So how can you just mention this Friedel reaction? What is Friedel reaction? ಏನಂತ ಹೇಳ್ಬೋದು, when aryl halides treated with a sodium metal in a dry ether gives a product in which 2 aryl groups are joined together alva. 2 aryl groups are joined together. So such reactions are called as what? Diphenyl or such reactions are called as what? Friedel reaction. I repeat once again, when the aryl halides are treated with a sodium metal in a dry ether, we get a product in which the 2 aryl groups are joined together. So such reactions are called as what? Friedel reaction. Okay, can you see? So in Woods reaction we have to can alkyl halide and we have formed a coupled product. Whereas in a Fittig reaction, we had took as what? Aryl halide, and we have obtained a coupled product of our aryl benzenes. Alva aryl groups ಏನಾಗಿತ್ತು join ಆಗಿರುತ್ತೆ. Now the question arises that why did I mention this Woods reaction? Of course there was a sign. Of course what we did, ಎರಡಲ್ಲೂ ಏನಾಗ್ತಾ ಉಂಟು, ಒಂದಲ್ಲಿ ಆಲ್ಕಿಲ್ ತಗೊಂಡ್ವಿ, ಇನ್ನೊಂದು ಅರೈಲ್ ತಗೊಂಡ್ವಿ. ಈಗ ನಮ್ಗೇನು ನಾರ್ಮಲ್ ಆಗಿ ನಮ್ಮ ಟೆಂಡೆನ್ಸಿ ಏನ್ ಬರುತ್ತೆ, ಸರ್ of course here we took 2 moles of alkyl halide and here we took 2 moles of aryl halide. Can we take, for example, if I am going to do this reaction, that is here if I am having one aryl halide of 1 mole and an alkyl halide of 1 mole in the presence of sodium and dry ether. In the presence of sodium and dry ether, what can the product be obtained was the question. ಏನ್ ಮಾಡಿದ್ವಿ, ವುಡ್ಸ್ ರಿಯಾಕ್ಷನ್ ಇಲ್ಲಿ ನಾನು 2 moles of alkyl halide ನ ತಗೊಂಡೆ. ಫಿಟಿಗ್ ರಿಯಾಕ್ಷನ್ 2 moles of ನಾನು ಅರೈಲ್ halide ನ ತಗೊಂಡೆ. ಕ್ವಶನ್ ಏನ್ ಅರೈಸ್ ಆಯ್ತು ಅಂದ್ರೆ, ಈಗ ನಾನು ಇದನ್ನ 1 mole ಇದನ್ನ 1 mole ತಗೊಂಡು ಕ್ಯಾನ್ ಐ ಡೂ ಮೈ ರಿಯಾಕ್ಷನ್ ಇನ್ ದಿ ಸೇಮ್ ವೇ? So when such a question was arise, there itself one reaction was called as what? Woods-Fittig reaction. Woods-Fittig reaction. So this itself is called as a Woods-Fittig reaction. So can you please help me? What will be the product? Alva. So ಇಲ್ಲಿ ಕೂಡ ಏನಾಗಬೇಕು, CC bond form ಆಗಬೇಕು. EX ಹೋಗುತ್ತೆ, EX ಹೋಗುತ್ತೆ, CH3 ಏನಾಗುತ್ತೆ. Yes. So this was my product plus 2NaX. ಬಂತಲ್ವಾ ನಮಗೆ toluene benzene ring which is attached to that of your methyl group. ಏನು common name, it is called as what? Toluene. So this is called as my Woods-Fittig reaction. So how can we write what is Woods-Fittig reaction? Alva. So when a mixture of my alkyl halide and an aryl halide are treated in the presence of a sodium metal, alva, this should be 2 moles sodium metal in a dry ether, gives me what? Alkyl arene. So what it is called as? Alkyl arene alva. Alkyl group unto arene group general ಆಗಿ ನಾ ಬರ್ದಿರೋದು, but actually its name will be what? Methyl benzene, or in common name toluene, but generally it will be called as what? Alkyl arene. So that is called as what? Woods-Fittig reaction. That is the reason when I was talking about my reaction with metals, I have also written what do you mean by Woods reaction. So that was the case, so that it would be easy for you to understand what do you mean by Woods-Fittig reaction. So in Woods I took my alkyl halide, whereas in Fittig reaction I took my aryl halide, which was treated with a sodium metal in a dry ether, and we got my coupled products. But when I am talking about Woods-Fittig reaction, what I am doing, of course from the Woods I am taking my alkyl halide, whereas from the Fittig I am taking my aryl halide. Then the condition is same. In the presence of sodium metal and a dry ether, I will be obtaining my what will be called as alkyl aryl group. Although alkyl arene sigutte, so that reaction will be called as what? Woods-Fittig reaction. Do remember guys, one of the important thing, so instead of sodium we can also use what? Activated copper is an additional information. Once again, activated copper you can use a lithium metal, you can use a zinc metal. So all these metals can be used. And also one important thing I want to mention, so whenever we are talking about these reactions, of course it may be a Woods, it could be a Fittig, it could be a Woods-Fittig reaction. So they all are what? Yes, they are all the examples of your coupling reactions. So they are all the coupling reactions. So, and one more important thing, remember, in all the cases we have to use dry ether. Why dry ether? Andre ಈ ತರ ಒಂದು ರಿಯಾಕ್ಷನ್ಸ್ ನಾವು ಕ್ಯಾರಿ ಔಟ್ ಮಾಡಿದಾಗ, ಕಪ್ಲಿಂಗ್ ರಿಯಾಕ್ಷನ್ಸ್ ನ ಕ್ಯಾರಿ ಔಟ್ ಮಾಡಿದಾಗ ನಮಗೆ ಮೇಜರ್ ಆಗಿ ಏನ್ ಬೇಕು ಅಂದ್ರೆ ಅಪ್ರೋಟಿಕ್ ಸಾಲ್ವೆಂಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅಪ್ರೋಟಿಕ್ ಸಾಲ್ವೆಂಟ್ ಏನಿದು ಅಪ್ರೋಟಿಕ್ ಸಾಲ್ವೆಂಟ್? ಸೊ ವೆನೆವರ್ ಯು ಆರ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ಅನ್ ಅಪ್ರೋಟಿಕ್ ಸಾಲ್ವೆಂಟ್ ಅಂದ್ರೆ ಅಪ್ರೋಟಿಕ್, that is the solvent should not give any protons. Okay, it should not be a medium of H+. So H+ ನ ಯಾವುದು ಕೊಡಲ್ವೋ ಅದನ್ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ಅಪ್ರೋಟಿಕ್ ಸಾಲ್ವೆಂಟ್ಸ್. ಸೊ ಡ್ರೈ ಈಥರ್ ಆಗಿರಬಹುದು, DMSO ಆಗಿರಬಹುದು, they are common examples of your aprotic solvents. So that is the reason medium is very much important. It will be difficult if you do it in your alcoholic medium or that of your water medium. So very specifically we have to use this medium dry ether. So whenever you are writing this Woods reaction, of course the sodium metal is also important and the medium is also important. And whenever the name they have given, Woods means you have to write alkyl halide, Fittig means you have to write your aryl halide. Woods Fittig means both your alkyl and the aryl in the presence of sodium dry ether is very much important. So these were the reactions with respect to the metals. So let me give you an additional information why we are calling it as a coupling reaction. So basically what happens means we can take this, that is I am going to explain this Woods Fittig reaction, its mechanism, basically an additional information. So basically it is having two important mechanisms which is called as an organo-alkali mechanism. Organo-alkali mechanism. That means what? First when you are talking about this haloarenes, first it will be treated with your sodium metal. So X badlu nimma Na hogurutte. Then what happens? E Na eno kutidiyalva. So this will be then treated with that of your alkyl halide. And then here use your Na. So then your Na gets substituted and there our CH3 come and sits. So this is called as what? Organo-alkali mechanism. Organo-alkali mechanism. Because it is an organic compound and sodium metal is an alkali metal. So that is the reason it's called an organo-alkali metals. But another mechanism also we see which is called as what? Radical mechanism. Free radicals in the yautara form agutte. Of course, recall the concept of what do you mean by free radicals. So whenever a bond is undergoing an homolytic cleavage, for example if I write A and B, homolytic cleavage and the symmetric bond break agದಾಗ ಏನಾಗುತ್ತೆ ಒಂದು ಬಾಂಡ್ ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ, ಇದರಲ್ಲಿ ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ ಇರುತ್ತೆ. ಸೊ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಒಂದ್ ಕಡೆ ಹೋದ್ರೆ ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇನ್ನೊಂದ್ ಕಡೆ ಬರುತ್ತೆ. ಅವಾಗ A ಒಂದ್ ಮೇಲೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇರುತ್ತೆ ಪ್ಲಸ್ B ಮೇಲೆ ಎಲೆಕ್ಟ್ರಾನ್ ಒಂದು ಇರುತ್ತೆ. ಸೊ ಇದು ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ರಾಡಿಕಲ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ರಾಡಿಕಲ್ ಮೆಕ್ಯಾನಿಸಮ್ ಹೆಂಗೆ ಅಂದ್ರೆ, ಸೊ ಫಸ್ಟ್ ಏನಾಗುತ್ತೆ, when you are treating for example your X is over, ಇದೇನಾಗುತ್ತೆ ಹೋಮೋಲಿಟಿಕ್ ಕ್ಲೀವೇಜ್ ಆಗಿ ನಮಗೆ ಫಿನೈಲ್ ರಾಡಿಕಲ್ ಸಿಗುತ್ತೆ ಇನ್ ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಸೋಡಿಯಂ ಲೈಕ್ ದಿಸ್. ಸೊ ಇಲ್ಲೇನಾಗುತ್ತೆ, ಫಸ್ಟ್ ನಂಗೆ ಫಿನೈಲ್ ರಾಡಿಕಲ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇರುತ್ತೆ ಪ್ಲಸ್ Na ಹತ್ರ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ, X ಹತ್ರ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಉಂಟು, NaX ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಅದೇ ರೀತಿ ಏನಾಗುತ್ತೆ CH3X in the presence of my sodium. ಸೊ ಇಲ್ಲೂ ಕೂಡ ಏನಾಗುತ್ತೆ, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಮಿಥೈಲ್ ರಾಡಿಕಲ್ಸ್ ಸಿಗುತ್ತೆ. ಅಫ್ ಕೋರ್ಸ್ ನಾವು ಯು ಕ್ಯಾನ್ ಓನ್ಲಿ ಜಡ್ಜ್ ದಿ ಪ್ರಾಡಕ್ಟ್ಸ್. ನೆಕ್ಸ್ಟ್ ಏನಾಗುತ್ತೆ, ಫಿನೈಲ್ ರಾಡಿಕಲ್ ಆಮೇಲೆ ನಮ್ಮ ಮಿಥೈಲ್ ರಾಡಿಕಲ್ ರಿಯಾಕ್ಟ್ ಆಗಿ ಅಫ್ ಕೋರ್ಸ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಮೈ ಮಿಥೈಲ್ ಬೆನ್ಸಿನ್ ಇನ್ ದಿಸ್ ವೇ ಅಲ್ವಾ, ಪ್ಲಸ್ ಓವರ್ ಆಲ್ 2NaX ಅಲ್ವಾ, NaX 2NaX. So this is the way of writing this is called as what? Radical mechanism. So when we were doing the experimental ಕೆಲ ಪ್ರಾಡಕ್ಟ್ಸ್ ನಾವು ನೋಡಿದಾಗ ನಮ್ಗೆ ಏನ್ ಗೊತ್ತಾಯ್ತು ಅಂದ್ರೆ, ಬೋತ್ ದಿ ಮೆಕ್ಯಾನಿಸಮ್ ಆರ್ಗ್ಯಾನೋಮೆಟಾಲಿಕ್ ಕೂಡ ಸಾಧ್ಯ ಉಂಟು, ಅದೇ ರೀತಿ ರಾಡಿಕಲ್ ಮೆಕ್ಯಾನಿಸಮ್ ಕೂಡ ಸಾಧ್ಯ ಉಂಟು. ಐ ಡೋಂಟ್ ವಾಂಟ್ ಟು ಗಿವ್ ಯು ದಿ ಎವಿಡೆನ್ಸ್ ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಸಮ್ವಾಟ್ ಆಫ್ ಹೈಯರ್ ಕ್ಲಾಸಸ್ ವಿಲ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ಡ್. ಐ ಜಸ್ಟ್ ವಾಂಟ್ ಟು ಸೇ ದಟ್ ಹೌ ವಿ ಆರ್ ರೈಟಿಂಗ್. ಯಾವುದೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ಕೆಮಿಸ್ಟ್ರಿ ನಾವು ಬರೀತಿದೀವಿ ಅಂದ್ರೆ ವಿ ಕಾಂಟ್ ಜಡ್ಜ್ ಆರ್ ವಿ ಕ್ಯಾನ್ ನಾಟ್ ರೈಟ್ ಇಟ್ ಆಸ್ ಇಟ್ ಇಸ್. ಅಫ್ಕೋರ್ಸ್ ಏನ್ ಮಾಡ್ತೀವಿ, ಫಸ್ಟ್ ವಿಲ್ ಡೂ ದಿ ರಿಯಾಕ್ಷನ್, ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಅವರ್ ಪ್ರಾಡಕ್ಟ್, ದೆನ್ ವಿ ಟ್ರೈ ಟು ರೈಟ್ ದಿ ಪಾತ್ ಆಫ್ ಇಟ್, ಯಾವ ತರ ಪ್ರೊಸೀಡ್ ಆಗಿರಬಹುದು ಅಲ್ವಾ. ದೇರ್ ಆರ್ ಮೆನಿ ಸ್ಟೆಪ್ಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈ ಫಿನೈಲ್ ರಾಡಿಕಲ್ ಅಂತ ಬಂದಾಗ ಕೆಲ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ ಇರುತ್ತೆ, ಆ ಫಿನೈಲ್ ರಾಡಿಕಲ್ ಬಂದಿದ್ಯೋ ಇಲ್ವೋ ಅಂತ ಚೆಕ್ ಮಾಡ್ತೀವಿ. ಓಕೆ ಬಂದಿದ್ದೆ ಅಂದಾಗ ಓಕೆ ನಾವು ಬರ್ದಿರೋ ಮೆಕ್ಯಾನಿಸಮ್ ಕರೆಕ್ಟ್ ಉಂಟು ಅಂತ ನಮ್ಗೊಂದು ಅಶ್ಯೂರೆನ್ಸ್ ಸಿಗುತ್ತೆ. ಅದೇ ರೀತಿ ಮಿಥೈಲ್ ರಾಡಿಕಲ್ ಸಿಕ್ಕಿದ್ಯೋ ಅಂತ ನಾವು ಜಡ್ಜ್ ಮಾಡಿದ ಆ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ ಇಂದ ನಮ್ಗೆ ಏನ್ ಗೊತ್ತಾಗುತ್ತೆ, ವಿ ಆರ್ ಗೆಟಿಂಗ್ ದಿ ಪಾತ್ that how does your reaction has proceed. So that is the reason whenever you're dealing with the chemistry, if you're knowing the mechanism, it is well and good so that you can easily judge the products. Instead of by hearting, it would be easy for one to write the products. Is that clear? So that is the reason I'm just giving you certain additional informations of the mechanism. Though of course some of you will get confused. For them I will just say that leave the mechanism. No need of putting an extra effort to remember it. Try to remember the named reactions as it is. Okay, so very much important. Those who can remember it, well and good. We can separate note of it, and you can just utilize those concepts in your further reactions too. Okay, so in today's video, what we have seen the electrophilic substitution reaction, and we came to know about the Friedel Craft's reaction, that is Friedel Craft's alkylation and Friedel Craft's acylation. An important thing is what is that we have to use in both the cases anhydrous aluminium trichloride, which will be acting as a Lewis acid as well as that of your catalyst. And this Friedel Craft's reaction are the examples of your electrophilic substitution reactions. So of course, whenever an electrophile is going to attack our benzene ring which is being bonded to the halogen, gives you the two important products. One will be your ortho and one will be a para substituted product. In that, our para will be the major, ortho will be the minor. Then we saw with respect to the reaction with metals, of course, whenever our chlorobenzene is treated with an sodium metal in the presence of dry ether, so they will be getting what? There's that reaction. Whatever we are going to get will be what? A biphenyl or a diphenyl. So that is an example of a Fittig reaction. Then also we came to know Wood's Fittig reaction, where we are treating our alkyl halide and aryl halide in the presence of sodium in a dry ether. We are going to get an alkyl arene, which is an example of your Wood's Fittig reaction. Very much important. So all these reactions, that would be a Wood's reaction, Fittig reaction, and Wood's Fittig reactions are the examples of the what? Coupling reaction. Yeah, that is the reason I said. So you can just see that how does the two fragments, alva. So this is why it is called as a coupling reaction. You can just see two fragments are getting joined together in the presence of what? Sodium metal. So that is the reason it is called as what? Coupling reaction. So these are the examples of what? Coupling reactions. Very much important. Where the two fragments are getting joined together. They are forming a bond between them. Okay. So that is the reason we are calling as what? Your Wood's reaction, Fittig reaction, or Wood's Fittig reaction as coupling reaction. Is that clear, guys? So in our next video, we are going to see the last concept of this chapter. Basically, it will be including certain advantages and disadvantages of certain alkyl halides and that of your aryl halides. Okay.